Guess you guys can hear me?
Yeah.
Okay, great.
And I guess you guys can hear me too. I think everyone can see David. And David, I'm correct, you're the Chief Technical Officer of Modern Meadows.
That's right.
And your colleague Gabor spoke here 3 years ago when he gave us an outline of some of your future plans and scared one or two of us about how he didn't think much of abattoirs, the leather industry, the lime yard, and that we were a very suitable industry to be closed down. Perhaps it would be interesting.
And that didn't go over well.
And that didn't go over too well. And you probably got the message from Richard's talk this morning and from the various lectures during the day that as an industry we are actually quite pleased on the way we've cleaned up our act over the last 50 years. And that Richard was saying that we didn't have a clear voice in the leather industry, which I'm hoping that we're managing to achieve with Leathernaturally. And since I have my boss here, our chairman, in the audience, I made sure I made that point clear. But what I think we would be seriously interested in, particularly since a lot of the people here were not here 3 years ago, both in understanding what you're actually doing and how you've moved forward technologically in the process in these last 3 years.
Okay, great. So first of all, thanks for having me here. I really appreciate it. So over the past 2 to 3 years, we have gone through a tremendous evolution, both as a technology organization, as a company, but also in terms of our understanding of the leather industry and the tanning industry and the associated technology that's been built, and really the perspective in terms of its environmental impact and place in the world. And so one of the things that, I think at any time you start a new company, you're in a place where you learn more and more about the existing industry and the people you can partner with. So that's been part of our ongoing evolution of our understanding as well. To be fair, I come from DuPont, a large industrial chemical company as well. And every industry has people who are exemplary, and you have people who are maybe not where you want them to be. And I think our understanding has gotten to the point where we see that both exist. And to directly address kind of the earlier conversation that maybe Gabor had, understanding that, there are things like Leathernaturally, there's Leather Working Group, and the targets that are there for that people are aspiring and are currently operating at. And that's what we aspire to operate at as well.
Now, I think what Michael Mayer was talking earlier about the building blocks of collagen is very much what you're doing here. The one thing that got missed a little bit in the fog of the discussion 3 years ago was how you were going to go about tanning that, because you're making effectively a putrefiable material, which will need tanning. What are your plans at that stage to move to the tanning side of things?
Yeah, so let me step back a little bit because and talk about, we're 52 people now as a company. And part of that is focused on developing the essential building blocks of leather, which is collagen, as Michael highlighted earlier, and the complexity that comes with that. One of the great opportunities when you work with a biomolecule like collagen is that you can create a lot of the aesthetic characters that people love in leather. The drawback, of course, is, or maybe not the drawback, but what comes with that is the fact that we have to tan it just like you would conventional leather. It's made of the same building blocks. It's built of collagen. So we have to tan it, we have to fat liquor, it has to be finished, the whole shebang. So it's really important for us to recognize a lot of the chemistry know-how that's been built and partner with the existing tanning industry as well. I think in the first instance for an initial product launch, we're not looking necessarily to work directly with tanners, but certainly in the fullness of time, to be able to have a material, like Lorica to some degree, where you can actually take the material and finish it as either a wet white or a wet blue or some sort of a mordant material, a crust material in the existing tanning infrastructure. It's really important. So the idea here is not so much that we're in competition with the existing leather industry. It's that we're really trying to elevate a new material. You know, it's collagen based, but our goal is not to create something that is fully recapitulated leather from a biomimicry perspective, but much more along the lines of, you know, trying to bring the best of what, you know, the protein structure of collagen can bring, along with all of the other material science that you can bring the two together. So it's really about elevating a new material that can stand alongside with traditional leather.
And are you going to be looking for partners here? How will you be choosing them? What's your plan in that regard?
Yeah, so I mean, we've been very lucky in that we've had over 130 companies approach us to work with us specifically to help develop products that are tailored to their specific needs and wants. So for us, it's been much more about being very judicious around who we want to work with, who we want to partner with. And so from a brand perspective, we're very judicious, and I think in the fullness of time when we do have a material that we can take out and work with an existing tanning infrastructure, to be judicious and make sure we're working with folks who are, you know, leather working, who are gold certified in the LWG and things of that sort.
One of the things the leather industry has been looking at hard in these last 3 years is how it can get away from tanning in aqueous solutions. So, I suppose 10,000 years we've been tanning in aqueous solutions, and as we heard from ATC, you stick the chemicals into an aqueous solution. In the first couple of hours, 90% of the chemical gets used up, and you spend a couple of days drumming away like crazy trying to get the last 10% in. You get 7% of it, and then you have to spend a lot of money cleaning up the water with the 3% that's left in it. Is this an area that you will be able to avoid going forward by building it from the biological pieces and having new reactive material available?
Yeah, so that's a really exciting area for us. So when you look at the fact that we're doing kind of a bottoms-up assembly, instead of trying to penetrate into the leather material, whether it's getting through this big grain in the coria, we actually have the ability to incorporate chemistry in a very unique way. That doesn't mean, on the other hand, that we don't need to go through, we couldn't in the fullness of time, operating inside of conventional tanning processes. But it also means that we have an option to perhaps introduce that chemistry earlier in the process, whether that's the tanning process or the lubricating process associated with fat liquor and things of that sort. So we have really the option to do both in this process. And you know, we're also excited about opportunities like the ionic liquids that are currently, there's studies that Will Weiss and the team here are looking at as well.
Ms. Gabor mentioned before, 3 years ago, that you could make all of your material look like calf skin, or all of it look like an elderly bull. You would have that choice. But another aspect that would interest us is that we sell leather based on its aesthetics and on its performance characteristics. And Professor Covington is always making the point that we've got a fabulous reactive three-dimensional substrate there upon which a lot can happen chemically. From your position, working with this as a raw material, are you going to be able to do more than just the aesthetics? Are you going to be able to work with the performance characteristics, the things like abrasion resistance, full waterproof, things of this sort?
Yes, I mean, I think that that's absolutely the case. I mean, so I think there's a significant percentage of folks who are excited about, you know, being able to mimic leather for the aesthetic qualities of it. But in reality, I think what's the most exciting for us is to be able to incorporate different fibers and different functionalities into the leather structure itself, because we can actually get those things intimately interwoven together. To be able to introduce new properties such as abrasion resistance or cut resistance, hydrophobicity, and other functionalities that you can put into the material. So, and certainly I think in the fullness of time, as we continue to develop the materials, we're going to continue to go down that road of really creating these biofabricated composite materials that are a mixture of the proteins of collagen and also all of the other synthetic materials that are out there today. Not unlike when you look at leather today, where they've really brought in the best of organic chemistry in the forms of the fat liquors and the tanning processes into the leather. Can we do something similar with material science as well?
And you did say they're in the fullness of time, and you also mentioned you're now 52 people. How do you see this scaling up? What sort of time scale and volumes do you see going forward over the next 5, 10, 15 years?
Yeah, so I can't get into the details around the next couple of years because the details around those product releases and things of that sort are confidential with our channel partners. But I would say over the next couple of years, we're looking to release our first set of products. And then initially it'll be a small volume launch to really understand how the materials behave in the marketplace, how they work in terms of actually behaving in the final end use. And then over time period, you're looking at going to significant volumes. I mean, the leather market traditional leather is a huge market. The synthetic leathers are another large market. And then of course, if you can produce a consistent material that solves the tanner's dilemma to some degree, then you can really go after materials that are almost like a textile, the holy grail of leather on a roll. And you're looking at volumes that are in the million to 2 to 3 million meters squared per year kind of volumes.
2 to 3 million meters square?
Per year.
10, 20, 30 million square feet, something,
Those
sort of
yep.
numbers. Excellent. I think that's all the questions I wanted to ask. Is there anything else you'd like to tell us before we ask anyone to blow on the fire?
We can open up for questions if you'd like.
So, do you want to take this or do you want me to?
Questions, anybody?
Of course, I have a question. So you're mentioning about chromed tannins, you were mentioning about fat liquors. And if you have a real material concept, why you do need this? You just have to make a structure which is similar to leather, but without any additives, not in collaboration with the chemical industry, of course. But just to simulate this structure and to construct the final material without these complicated systems and complicated additives, it would be a big advantage, I think.
No, I think that's a great point. But I guess to some degree, some of the unique aesthetic quality of leather comes out of a lot of the synergy between the chemical systems and the macromolecules, the collagen fibers, bundles, fibrils that are all together there. So I think it's a balance of trying to make a great performing material, but also make a material that has the aesthetic qualities that people have grown to love and cherish. So I think to some degree it's a balance. That doesn't mean to say that there's so many opportunities here over time that in terms of layers upon layers of innovation that we can start to think about building in, that you wouldn't do something like that. And then certainly as we think about those opportunities, we do look down the road towards them. It's just probably not the first thing we would do.
Any more questions? I have one actually. What are you going to call it?
I was waiting for that question. So I think what we want to call it is a challenging question to answer, right? I mean, we recognize over the past 3 to 4 years the complexity of what you call a material that you call leather, right? If you look at the definition of BS 2780, where it's very clear around the origin of the material in order to be called leather, it's clear that it's a real minefield. So over the next year, we're looking to come up with exactly what we're going to call it. And really what we would like to do is be able to reference leather, just because there is so much value that's generated from what people appreciate for leather, but not necessarily say to call it leather. So for right now, we call it biofabricated leather material. It's probably the most unsexy brand name you're ever going to come up with. And we're going to kind of flesh that out over the next year. But it's clear that the definition of leather in its entirety really connotes a material that goes all the way back to the animal.
I'm going to ask you quite a basic question. I mean, some of it relates to what Mike mentioned earlier. In leather, we have fundamentally the fiber structure. It has porosity, and it has a great strength, and a lot of its properties relates to that, apart from the aesthetic aspects. To what level does your product have similarity with leather? So if it is not similar, are we going to consider it as another sort of polymer material? Will it look like that, or will it look like a real leather? How will it look like?
Yeah, so I think it's the answer to some degree is a function of when we take a snapshot in time where we're going to be when it launches. We're looking in terms of launching material that's multi-generational in nature. We can continue to add on complexity in terms of properties, complexity in terms of structure over time. What I would say is that we are a collagen-based material, which means that we have, as Michael highlighted earlier, we do have collagen fibers and fibrils that come together. And we respect and understand the hierarchy of structure that you have in leather, between the interplay between the grain, with the corium, and then that interfacial layer. And really, if you look at leather, so I'm a material scientist by training. And when I look at leather, I see one of the most beautifully complex material structures that I've seen in terms of the layers of complexity and how it can bear a load. And I think ultimately that would be the kind of level of complexity we'll work our way towards. So, not trying to dodge your question, but it's going to be it's not something in the first instance we're going to roll out with a fully biological leather. It'll be something that meets our targeted customers' wants and desires, which is a little bit different than maybe a fully functional mimic of biological leather.
Thank you. I'm just wondering, probably just to get your thoughts on this, what is the inspiration behind making artificial leather? Because we know leather is a high performance material and nothing we compare to it. What is the inspiration behind this?
So to some degree the inspiration is really the result of, biotechnology has evolved tremendously over the past 20 to 30 years. And it's allowed us to bring certain tools from a biological perspective into play in combination with the material science that's evolved. So to some degree, this is about taking the best of what modern science can bring forward today and create a material that has a lot of the beneficial properties of leather, the breathability, the warmth, the feel, the way it can move over time, with some of the synthetic properties. So the inspiration is, it's a great material. People are always looking for leather. They love the way it feels in the aesthetic side, but they also love the high performance character. So if we can come close to that properties or maybe differentiate ourselves in other characteristics to bring something that's slightly different, there's a huge market opportunity out there for that.
Sorry, just a quick question here. I think my main questions have been asked already and you've answered them. So just a basic question. Obviously, to build collagen, you need amino acids. Do you source those in pure form? And that would be a big driver of cost, I would imagine.
So I can't answer your question in its entirety because it really goes back to our core technology on how we're enabled to do this. But what I would say is we've developed a process that allows us to scalably produce our collagen materials cost effectively.
Okay, because you need it in the right proportion, and some amino acids are fairly expensive and difficult to get in pure form. Unless, of course, you take a hide and break it down into amino acids and then...
So what I can share with you is we're not using peptide synthesis to make these.
Okay.
So anytime you make a peptide longer than about 7 to 11 amino acids, it becomes very cost ineffective.
Thank you.
Could I ask you about your business model? I mean, my understanding of Model Manor in the past was that you were going to sort of be based around making synthetic meat, sort of meat, animal-free meat. Are you changing your model now away from that and more focusing on sort of making leather? Is that going to be the core focus now?
Yeah, so I would say that the answer to your question is yes, but let me couch it a little bit. Even if you go back to as early as Andras Forgax, the CEO's first TED Talk, we actually described materials as being kind of the real first major launch target. and meat being kind of a secondary target. What we have learned over the past couple of years is that we need to focus, and it really makes the most sense for us to focus on the materials side of the business as opposed to the food side, for a whole host of really great business reasons. And then we'll figure out what we're going to do with our technology we've developed around meat going forward. But right now, we're really focused on getting products to market in the material space.
So that would mean then that the cows and the sheep that are in the field at the moment will still be required for meat.
So that's true. But to be fair, if you look at the scale from a global perspective, on the amount of protein that's generated, from cows and sheep and what have you, versus what's produced via an alternative protein source, the scale of the two are quite different. So even a blockbuster business in terms of launching an alternative protein business would be relatively minor in comparison on an absolute magnitude.
Any more questions?
Leather has a lot of problems because of the way the animals have been treated with scratches and forks and things like that. But a lot of the joy of leather certainly is in the grain structure of the leather, and I don't understand quite, without embossing, there's putting some sort of embossing on it, turns it into a pigmented embossed leather, how you're going to get an aniline type looking leather with a grain on it.
So what I would say is one of the things we do very well is we do make a very good grain. And the structure you get out of that material, that comes out of that grain material, that's inherent in our process and is very controllable, allows us to dial in the aesthetic properties of that grain. So that is one thing we do very well.
Follicle effect, so you can see follicles?
So we aren't able to duplicate the follicle effect, although we can tune our process to generate a similar type of aesthetic process. And one thing I think we've heard loud and clear is the idea of you don't want to continue a homogeneous material. You want a material that actually has controlled variation. And that's also part of the process design as well.
Yeah, thank you. It's a very, very interesting presentation. I've got a couple of queries, and I'm coming from a leather manufacturing base, which is not my familiarity. It appears to me in a few years you're talking in terms of producing quite large volumes of this product, and it seems to me that over the years there's a couple of points. One is that the leather industry works with an irregular material, and it's selling chunks of an irregular material, let's say up to 50 square feet in size, and that's what they are accustomed to working with. So would you be selling units in this sort of size? But the other thing is, which is a bit more important, that tanners have seemed to have gone in one of two directions. One, they're either making quite a lot of quite bespoke material, lots of different textures, substances, colours, but for very niche markets, or otherwise they're making a much more generic product, say large shoe manufacture or automotive. Of course, the automotive goes on to selling patterns and boxes as opposed to boxes of components. So there's sort of two routes to follow. And I wondered if you had thoughts in one direction or the other, a bespoke route or a generic route.
Yeah, so let me, it sounds like there were three questions here. The first question is, would we be able to provide a material that the tanning industry can adopt directly into the pre-existing infrastructure based on size and width and things of that sort? And I think that that's the intention, is to create a material, not right away, but in time, that would more or less operate as a drop-in material. Your second question was really around a business strategy. Would we provide a material that could go down the bespoke side versus something that's going to be kind of a long-run, very standard material? And I think that's one of the real values, actually, is in terms of engaging the tanning industry, is that it offers the opportunity to provide that raw material. And then you can introduce that variation from tannery to tannery, tanning process to create a more bespoke-like material that's often highly sought out in terms of the leather products that are out there. So I think the answer is, and not trying to be cagey, but yes. But I think it's a recognition of what market, you guys can probably hear me without the microphone, actually. What market you would be targeting the material towards.
One problem we have as an industry is our whole issue of supply and demand of raw material. Can you envisage a situation where we, as tanners, could meet the demands of our customers by supplying us with the raw material that we can then tan and take through to a leather-like product, whatever it's going to be called, at a price that actually keeps us in business and competitive, and takes away those issues of price fluctuation of raw materials and price and availability of raw materials?
No, I think that's a great point. And one of so to answer your question, I think the idea would be to be able to provide a material that could stand alongside, a hide, go into the tanning process, solve the tanner's dilemma, so to speak, right, of having a consistent material. And also, to some degree, would allow people to flatten out the supply-demand variation that you see. And to some degree, because we're able to rely on biotechnology versus growing an animal, it also allows us to have a very stable supply relationship in terms of providing that material. So you won't struggle with the season-to-season variation of the supply, the year-to-year supply movement that happens from time to time.
You haven't actually mentioned how you tan your material. Could you tell us a little bit? Could you tell us a little bit how you tan your material?
So I can't go into full detail, but we use all the classic tanning chemistries that the leather industry uses. So we're very familiar with glutaraldehyde, GTW. We're familiar with chrome, and each have their merits when done responsibly, right? So we look at the full range of chemistries that are out there, and really working with some of the best chemistries that we can work with for that natural technology. So it really just depends on what you're trying to do.
3 years ago, it was me that picked up your colleague, and at that point, between the hotel and here, he didn't realise that collagen had to be stabilised and actually tanned. He was under the impression at that point that all he had to do was produce collagen. So I explained to him that it is actually the stabilised form that you can then turn leather. Had the journey gone a little bit longer, I would have also said that what you're doing can only be part of the materials industry and never the leather industry, and that you are, as a DuPont person, a materials person. And so you can't really consider yourself as part of our industry. Do you see that?
Well, so I appreciate your perspective, and I can assure you that our evolution and understanding around the tanning process and its role in stabilizing the collagenous structure has evolved as well, I'm sure. And what I would say is, technology I look at technology as an enabling capability, right? If you go back through, I think Tony did a great job earlier of going through and talking us through how chemistry evolved within the leather industry, and how at one time it was veg tan and then it became chrome. And I think to some degree to view the technology we're bringing forward in a similar light, not that it comes from an animal, I'm certainly not trying to say that it comes from an animal, but to view it in terms of an alternative material that can be handled in a very similar way, that offers a different but similar set of properties. Maybe give us a little bit of a chance and see how we can do it, right? Because
It'll still be part of the industry.
So I hear you, but to be fair, collagen in and of itself is an amazing biopolymer, right? And we like to think of ourselves as really just doing nothing more than expanding the palette that we can operate in within that polymer space by starting with a biopolymer like collagen, and maybe augmenting it a little bit.
The reason I make the point is at some point you're going to want to say that you're leather in the car.
So we've evolved a lot in our thinking around this, and the fact that, yes, people write about us as though we're leather, and it's because people love leather, they revere it, they want to talk about it. In our perspective, it's not so much saying that we are leather, as it is being able to really differentiate ourselves on the property set that people are looking for.
Good, thank you. Thank you very much, David, for coming back to us and
offering further explanations. It's very interesting, and I think we'll see you more to come in the future.
Thank you. Appreciate it.